Yeah, as you stated, I was at Caltech and Harvard, a computational neuroscientist, and since then I've been at OpenMail, and it's been a great home. I've learned a lot, and we have some fun problems. And we're recruiting too, so reach out. Can you hear me, everyone? Is that better? Yes. Okay. Sorry. All right, so I'm doing my whole talk in IPython notebook to kind of demonstrate its usefulness. So we're going to start by using Pylab inline, which populates the IPython space with NumPy and Matplotlib. Most people have heard of Matplotlib. It's sort of the ubiquitous plotting library for Python. Yeah.
Kind of running joke in the back about the font size throughout all the talks. Can you make that bigger at all? There we go.
Better?
Yeah.
Okay. All right, so Matplotlib is a stateful scripting interface for generating graphics similar to MATLAB's syntax and appearance. Matplotlib renders to a backend, which is usually a raster graphics canvas. And the strength of this approach is that once rendered, the data loads into a web page as an image, and so it's really fast. For IPython notebooks, where you have lots and lots of plots, because it's in a web browser and they're optimized for images, it's sort of a good fit. So the first example I have is just simply you want to plot two axes, and you can use this TwinX function. So you just assign the right-hand axes to your second plot, and then you can customize the color and the font size and all of those aspects of it. For the next example, I was using subplots to show an array of axes, which you can access with an index, and then you have the different functions like scatter, step, bar, and fill between the curves. You can provide a label, and then you can display that in a legend, and you can select the location like the upper left. IPython has recently introduced interactive widgets that tie together the Python code running in the kernel and the JavaScript, HTML, and CSS running in the browser. For those of you that know Mathematica, it's a lot like the manipulate command. It works by repeatedly calling the function that renders the graphics with the new variable values, and then generates a new image on each iteration. This can be slow if your data set is big. So for this example, I'm using the NetworkX library and using some different network graphs, which we have in a dict here. And yes, and let me evaluate this. So you can just move the sliders around, and it updates the image below. And you provide the ranges, and you can provide sort of the set point where it starts at, and you can, it creates the drop-down menus for you, for your dictionaries. And then one of the most ubiquitous use cases is to save publication quality figures with this. And to do that, we use the PDF backend to Matplotlib. This generates our figure as a vector graphic rather than the raster graphics. So you see here how we call the backend PDF. And then you assign the name of the file name that you want to create, and then you do your figure plotting, and then you just do PDF save fig as the function. And you can call that multiple times with multiple different figures, and it'll save multiple pages to your PDF in the same file name. All right, so Seabourn is a statistics library that sits on top of Matplotlib. It's really tightly integrated with the PyData stack, including NumPy and Pandas data structures, and built-in statistical routines from SciPy and stats models. The nice thing about it is it has great default color palettes, and really simple to use built-in defaults for statistical plots. So you don't have to do as much tweaking to get really sophisticated results like you would in Matplotlib. So you just import it, and then these are some of the color palettes I wanted to show you. So they have diverging ones, which are useful when the data has natural breakpoints you want to make visible in the color map. They have qualitative color palettes, which are great when the data is categorical and you're doing bar plots. And then there are sequential data color palettes, which you use when the data range is ranging from high to low. And among those is the CueHelix color palette. So Matplotlib has its own default, which is shown right here. And it kind of has a set linear step size between the colors in the map. These are nice because they preserve all the information in the color map, even if you're just printing it in black and white, or if it's viewed by a colorblind individual. And Seaborn adds a little more flexibility to the CueHelix. You can change the size of that linear step and also the start point, so where in the hue color wheel you are. My favorite function in Seabourn is the joint distribution plot that allows visualization of bivariate distributions and its marginals. So you can see it here. And it's similar to a histogram, but it encodes the number of observations in each bin with color instead of position on an axis. And then another great statistical plot that I like to use is the violin plot, which conveys the same information as a box plot. It shows the median and the 25th and 75th percentiles, but it adds the shape of the distribution. And then in Seaborn, you can also show the individual observations. So on the left, you can show them as points, and on the right, you can show them as lines. And it's nice to get like a good sense of what your data looks like. The next library, so those two are kind of static images for the most part. They're not as interactive. Now we're going to move into two libraries that are using HTML canvas. They're much more interactive. So the first one is MPLD3. This allows using the same syntax as Matplotlib plots, but it's using the D3.js JavaScript renderer. So for those of you that don't know, this is a very popular JavaScript library for interactive data visualizations on the web. And you can add custom JavaScript plugins for the interactivity and then export it as standalone HTML, or you can view it in IPython. And you benefit from GPU acceleration. So this library and the next one, it's good if you're looking at real-time data, or you want interactivity with thousands to tens of thousands of data points. One of its weaknesses is that if you do want to create custom interactivity, you need to know JavaScript. So that's a drawback. So here, this is a built-in linked brushing plugin, and this is great for when you're exploring high-dimensional data. So you can display that data in multiple two-dimensional plots that are slicing it in different ways. And then you can just select like a subset of points, and you can see how that looks in the different 2D slices of your data and see the relationships. All right, the next example I got from a blog, Pythambic Perambulations. And this is creating a custom JavaScript plugin that allows us to hover over points in a scatter plot and see what that waveform looks like. So you can see the JavaScript plugin that you have to define. And so here, when you hover over the points, it shows you the different waveforms, which is really fun. And then it also has some interactivity in terms of being able to pan around the screen if you want to, and also zoom in to subsets. Bokeh is the other web visualization library for Python. This one, so MPLD3 is using the same syntax as Matplotlib. Bokeh has its own modern grammar for graphics, but it's doing D3-like HTML canvas graphics for large and streaming data sets. You don't have to know JavaScript for this. It simplifies it and has lots of nice built-in tools for interactivity. So for my first example, let me just cover this first. So you import your Bokeh plotting module, which defines the graphical functions and primitives, and then you use this output notebook, which is telling Bokeh to display the HTML plots directly into the notebook. So here we just do a quick little scatter plot where we're using the circle glyph to display the X and Y data points. And so there are these different interactive features, and this is sort of the default set, and you can select which of those you actually want viewable and usable. So you can just do a zoom if you wanted, or just panning features. And you can reset them. You can do a box zoom if you want to look in a little area. All right, and then another nice built-in tool is a tooltip, so on hovering. So here we're reading in a Bokeh sample data set that shows US employment data. And we're just doing a little bit of shaping the data and getting it how we want it to look, and then we plot it. And we're doing the month by year. And then as you hover over, the nice thing about Bokeh is that it understands the semantics of the pandas data frame. So you just need to specify, what you want to see, and you don't. There's not much work to do in the tooltip and how it populates it. You can also use R in IPython, so there are a lot of people here familiar with R. So you import the rpy2 library and use this macro to load the extension into the IPython notebook. And that allows you to just prepend all your R commands with this %R, and then you can just run anything like you would run in R in the IPython shell. So you can switch back and forth if you want. So this example, these plots are created by R, but they're displaying in the IPython. So this is a Bayesian change point library that I'm using. I'm just creating a little example data there. So you can use ggplot if you're familiar with that in IPython. Matplotlib itself also has a ggplot style sheet. So if you go to the Matplotlib example gallery, there are different style sheets, so you can create plots in Matplotlib that look just like R as well. And then the last example is VisPy. So this is using OpenGL, which is, the use case is when you have very, very large data sets, 100K or more, and you want to do stuff real time with it. So lots of OpenGL libraries out there. There's VisVis, Gallery, Glumpy, PyQt. And the developers from all of those recently got together and decided to build one single master Python OpenGL visualization library. But it's very new, it's very under development, it's very buggy in my experience. And it doesn't really have a lot of built-in plotting tools yet, but I have a lot of hope for it getting there. They've already shipped a basic experimental OpenGL backend from Matplotlib, so if you really want to play with that GPU acceleration that OpenGL gives you, you can try that out. It's kind of targeted for two different kinds of users, those who already know OpenGL, and they want really fast interactive visualization in Python, and then scientists who need really high performance plotting tools. All right, in this example I'm going to run live. I'm doing a game of life demo. So here you're just, and I'm going to provide this notebook afterwards, so it'll be available on the DataScience.LA, and you can play with it and tweak it as you want and go into a little more depth. I'm just trying to give a quick overview. So this defines the OpenGL here, all of this code. And then this code is defining the Python behavior. And then you just open a canvas and show it.
Cool.
And you have your little gun. Sorry about that. All right, and that's what I got for you guys, so I'll take any questions. You can save them as HTML standalone objects. And the MPLD3, you can also export the JSON for it.
So I really like IPyNotebook, but one of the troubles I have is how to visualize the variables that are in memory. Is there an easy way to see what's going on without having to reset the kernel every time you get lost? I guess not. Never mind.
That one I don't know, sorry.
Between the R and the Python, it sounds like you're using them both as far as graph and ggplot versus the Python plot versus visualization. Do you have any compare and contrast when we're going back to R? ggplot, something you can't get done in Python?
These days I mostly live in Python. I was just putting it there because I know a lot of people from the R meetup were showing up. So.